a display of lights above the storm. Presented by Science at NASA. In 2015, European Space Agency or ESA astronaut Andreas Mogensen was on board the International Space Station, or ISS, photographing the tops of thunderstorms from Earth orbit. And he saw something very interesting indeed: blue jets. Blue jets are a type of transient luminous event, or TLE, flashes and glows that appear above storms that are results of activity occurring in and below those storms. Blue jets pulse from the tops of intense thunderstorms and reach up toward the edge of space. In January 2017, researchers at Denmark's National Space Institute published their analysis of his observations in Geophysical Research Letters. Mogensen was able to capture clear video as the station flew over the Bay of Bengal, and they were amazed by what that video showed. Olivier Chanrion, lead author of the publication, reported that during 160 seconds of video footage, 245 pulsating blue discharges were observed, corresponding to a rate of about 90 per minute. One of the blue jets observed reached 25 miles or 40 kilometers above sea level. Visual evidence of TLEs wasn't available until 1989. Early evidence included red sprites photographed by cameras on board the space shuttle and photographs taken during a NASA and University of Alaska airborne campaign. Red sprites are glows in the upper atmosphere tied to the presence of large lightning flashes but not attached to the clouds themselves. In recent years, the ISS has afforded astronauts the opportunity to photograph a number of natural light shows produced at the tops of thunderstorms. A 2013 study by researchers from the French Alternative Energies and Atomic Energy Commission analyzed pictures from the NASA Crew Earth Observations Facility aboard the station. The pictures revealed 15 sprites and their apparent lightning flashes. In August 2015, the Expedition 44 crew on board the station photographed red sprites over 2 different storms within 3 minutes of one another. First over the American Midwest, and then near the coast of El Salvador. These sprites reached as high as 62 miles or 100 kilometers above the surface of the Earth. All of these studies are contributing to researchers' understanding of lightning and thunderstorms, how they form and develop over time, and why storms produce different TLEs in different circumstances. However, according to Tim Lang, atmospheric scientist at NASA's Marshall Space Flight Center, TLE studies have been, to an extent, fortunate observation. We've gotten better at finding them, but it's mostly case-based analysis. NASA and partner agencies are advancing in their efforts to make continuous storm observations. NASA's Lightning Imaging Sensor, or LISS, was installed on the International Space Station in February 2017 as part of the DoD Space Test Program. LISS on the station is the latest in a line of instruments used to locate and detect lightning over a large region of the Earth's surface. The Atmosphere-Space Interactions Monitor, or ASIM, will be installed outside Europe's Columbus Laboratory on the ISS later this year. Torsten Neubert, ASIM principal investigator, says, "The instruments will monitor thunderstorms and their effects on Earth's atmosphere, gathering information about blue jets and other TLEs, as well as flashes of X and gamma rays. LISS and ASIM will be providing data that gives researchers the opportunity to analyze storms from both below and above. All of these studies are adding to our knowledge of how storms evolve and change, helping improve storm models that could lead to better predictions and forecasts." For more science from above the clouds, visit www.nasa.gov/station. For electrifying updates, stay tuned to science.nasa.gov.
Space Coffee, presented by Science at NASA. Astronauts on the International Space Station give up many pleasures to take those giant leaps in the name of science. They leave behind fresh vegetables, relaxing hot showers, warm sunshine, gently misting rain, and much more. One of the things astronauts say they miss most is a good cup of coffee. How would you like to start your morning sucking freeze-dried coffee through a straw from a sealed plastic bag? Good news for astronauts. Morning Joe recently got an upgrade. On April 20th, SpaceX delivered to the space station a new microgravity coffee machine named IS Espresso. Our aerospace engineers have designed a coffee maker that can function in microgravity conditions, says David Avino of the Italian engineering firm Argotec. Working together with the coffee company Lavazza and the Italian Space Agency, we have brought authentic Italian espresso onto the International Space Station. No one wants to drink Italian espresso from a plastic bag, however. What astronauts need is a zero-G coffee cup. Fortunately, 6 of these wonders have been delivered to the space station as well. Fluid physicist Mark Weislogel of Portland State University and IRPI LLC, who helped invent the cups, explains why they are necessary. If you try to use a regular coffee mug, you might not get the coffee to your face, says Weislogel. It would be trapped at the bottom of the mug. In low-gravity environments like the space station, fluids tend to get sticky. Surface tension and capillary effects, which are overwhelmed by gravity on Earth, rule the day in space. As a result, coffee tends to cling to the walls of the cup. You could dip your tongue in the cup and lick the hot coffee out, or you could throw it out of the cup and suck down the scalding blob that forms in the air. No thanks. The zero-G coffee cup solves these problems by going with the flow, putting the strange behavior of fluid in microgravity to work. Basically, explains Weislogel, the liquid piles up right at the lip of the cup and keeps flowing as you sip. It pours out by the combined effects of your mouth, the wetting conditions of the fluid, surface tension, and the particular shape of the cup. This oddball cup wouldn't work on Earth, but it is a marvel in space. Weislogel and colleagues learned how to make the coffee cup by conducting capillary flow experiments on board the station. For years, they've been studying how fluids on the station climb the walls of their containers, turn corners, and perform other maneuvers that defy earthly intuition. It's not all about the coffee, he says. We need to understand how fluids behave in any container. The operation of many critical space station systems, air conditioning, refrigerators, toilets, cryogenic fuel tanks, medical treatments, the water supply, and everything else that involves liquids depends on the ebb and flow of fluids. These systems must work without gravity if they're to be used on the International Space Station or on a spaceship en route to Mars, he adds. Compared to those other systems, coffee is not in the critical path of operation, says Weislogel. Try telling that to the astronauts about 5:30 tomorrow morning. For updates from the International Space Station, go to www.nasa.gov/station. And for more eye-opening science news, stay tuned to science.nasa.gov.